So there is a mini quiz that I hope that will help you to understand the molecule, and by looking at the picture you googled, you can tell that what compound it is. Is it whether injectable or oral compound, and what family it belongs, and possibly identifying the molecule exactly. So let's take a look at the molecule you see. On between 4th and 5th positions, it does not have a double carbon bond. So it seems like it is a DHT. Let's take a look at the 19th position. It seems like it is still a methyl group, CH3. So it is not a 19 testosterone group. Still, okay. And let's take a look at the 17th position. It has an added methyl group, so possibly DHT, injectable. It is a DHT molecule, it is injectable, and also it is 5-alpha reduced. It's not testosterone, it's a DHT molecule, an orally active DHT derivative. But it has a different thing. You can see that on the 2nd position, it has an oxygen atom. So it's not a DHT itself, it's a derivative, and thus it has different effects. So possibly the possible explanations are, it might be that molecule itself might be an anadrol, superdrol, oral primobolan, which is technically not C17 alpha alkylated, but it is an oral preparation. It's an oral drug. Orally you can find. It might be oxandrolone or Winstrol, aka stanozolone. So why? Let's talk about why it might not be the superdrol. Probably you might have previously at least heard about that superdrol is technically C17 alpha alkylated version of the drostanolone. Assuming that you know the molecule of drostanolone, you know the molecular structure of drostanolone, you can say that, okay, it's a derivative of drostanolone, so it's not superdrol, by looking at the molecule itself. Why? Let's talk about also about why oral primobolan acetate cannot be that molecule I've shown you. It's because oral primobolan acetate is not, IOP, is not a C17 alpha alkylated drug. Technically, you can inject it. So, as you can see on the slide, primobolan acetate does not have a C17 alpha alkyl group. They didn't add a methyl CH3 on the 17th position. Also, it still has the ester attached to it. So it is not a highly orally bioavailable drug. So the possible wrong answers are on the left side on the screen, you can see that above you see the drostanolone molecule, aka masteron, and below that you see the superdrol. Superdrol and masteron acts drastically as different characteristics, and one is super liver toxic and the other is not. So plausible answers are oxandrolone, the remaining are oxandrolone, stanozolol, and oxymethanol. You see, you just got rid of the remaining 19 nortestosterone, possible 19 nortestosterone groups, testosterone groups, and other DHT groups too. So, as you might have previously as you can remember, there was a distinctive difference between the DHT molecule itself and the molecule I've shown you. And that is the oxygen atom on the second position. So, if you look at the second position of the molecule on the very left on the screen, you can see that it has oxygen atom. So, what I've shown you was the oxandrolone molecule. Here's the second mini quiz that I hope that will help you to understand those molecules better. So I'm not the molecule expert, I'm not a biochemist, but I know the basics very well. As you can see on the molecule itself, that molecule is 5-alpha reduced, seems like. Also, when we take a look at the 19th position, it likes the carbon group. And at the 17th position, it lacks the methyl group. So, not technically lacks, it does not have an added methyl group to 17th position. So, it is possibly an injectable drug. Seems like 5-alpha reduced. And also, seems like it is a nandrolone derivative, 19-nortestosterone derivative. So, you might ask that, what the hell it is actually? Is it a DHT drug or is it a 19-nortestosterone family drug? The answer is, it is technically a bit of both. Remember that structure is very similar to nandrolone's structure. That structure is identical to testosterone itself, except the two modifications. It lacks the carbon on the 19th position, and it is 5-alpha reduced. Remember that also nandrolone lacks the carbon on the 19th position, but still has the hydrogen atom. So the only difference between the molecule I showed you and nandrolone is the only difference between the nandrolone molecule and the molecule I showed you is 5-alpha reduction. So it means that it is technically the metabolite, 5-alpha reduced metabolite of nandrolone, which is the hydronandrolone. Also, as I previously told you, the hydronandrolone, when it gets 5-alpha reduced to the hydronandrolone, it gets even androgenically, at least, it gets even weaker. It becomes even less androgenic. And that's it. That's end of the slide, and that's the end of the video. If that video was helpful to you, don't forget to comment, subscribe, and share. And as always, as I always tell you, till next time, take care. Have a great day.